Hey everybody, this is lesson 8.6, and we're going to continue this idea of using scatter plots to actually solve real-life problems. Okay, so in the first lesson on scatter plots, 8.5, we talked about positive trends, negative trends, correlations anyway, and then no correlations. And the basic idea was, look, we got a bunch of data, we're going to try to put a line through them that fits the data as closely as possible. All right, now, this is kind of part two of why we do that. So the whole idea is once you've got that line, you ignore all the dots, and you use the line to make predictions about what's going to happen. All right, so let me give you an example. This is right out of your textbook if you want to follow along. Okay, so suppose that we've got some data, and this data is by Isle Royale Park, which is in Michigan, and let's say that every year from 1982 to 1999, they go out and they count how many wolves they think are living in the park and how many moose are living in the park. Okay, and then what we're going to do is we're going to do a scatter plot of all of this data, and we're going to see if there's any trends. We're going to see if we can make any predictions, and we're going to talk about how the moose populations and the wolf populations seem to kind of go hand in hand. Okay, so that's the basic idea. All right, so let's talk about what a scatter plot from this data would look like. Okay, each of the years is going to be a point. Don't worry about the years. That's part of the reason they're a different color. So that records when the data happened. But what we're going to do is we're going to need one variable to be the independent variable and one to be the dependent variable. Now I want you to think about it. You could argue that the wolf and moose population are interdependent, but I think our intuition is going to be if there's a whole lot of wolves, that's probably going to negatively affect the moose population. Okay? And so let's see if that's actually true. So why don't we make wolves the independent variable? So based on how many wolves, we'll try to make a prediction as to how many moose we can expect to find. All right, so that said, I'm going to do a lot of the work for you. So here's the heavy lifting. Let's go right to the next slide. So here's a scatter plot where along the bottom we have number of wolves that were counted. And again, go back to your data here. It looks like the number of wolves is always between about 10 and 20. There's a high of 25 wolves in 1999. I think the low number of wolves was 11 back in 1989. So we bid pretty much, you know, we could go from 10 to 25. Or we could start at 0 and just go right from 0 up to 27. Okay, same thing with the moose populations. The lowest moose population is a little less than 600. And they go all the way up to 2,400. All right, so using my graph paper, every 150 going up is going to be the moose population, and every 1.5 going across to the right will be a wolf. And so we've labeled multiples of 3 or 300. All right, that's the setup. Notice there is a title on this graph. Notice that I have labeled both of my axes, both the independent number of wolves and the dependent number of moose. And sure enough, if I graph all of the little red dots for all of those years, with the exception of, and I kind of just accidentally covered over it, so I'll erase that little spot there, with the exception of maybe that one piece of data right there, and maybe this one, that one's a little bit far off too, but most of the rest of these are pretty close to that black line that I've already drawn in. And so I would argue that that's a pretty good trend line. Now you might argue, all right, maybe it shouldn't be sloped down quite so steeply. Maybe it should be just a teensy bit higher, but that's pretty good. Okay, about half the data is above it, about half's below. And I would say that's, with the exception of those two outliers that I've circled in green, that's a pretty strong negative correlation. All right, now what I want you to do for a second, this line was generated by drawing it through the red dots. That's the scatter plot. Now, ignore the scatter plot for a second. Suppose I asked you to make a prediction about how many moose we'd expect if we counted 9 wolves. All right, well, let's just go over here, and let's go to the graph, and right here we see 9 wolves, okay, corresponds with a point right about here, and that looks like it's a little less than 1,800, so maybe about 1,700 moose if there were only 9 wolves. All right, let's say the number of wolves goes up to 20. All right, now 20 is a little hard to find. It's going to be 20.5 would be right about here, so 20 is going to be right about there. And if I go up, actually, that's almost one of my data points, as well as the point on the line. And we can see it's a little bit less. We're counting by 150, so that would be about 1150, about 1140 moose. Okay. Let's say the number of wolves keeps increasing. Let's go all the way up to 30. That would be the end right here. So if there were 30 wolves, our prediction line, see, this is past any of the data. We didn't have any data counts that had any more then it looks like about 25 wolves. So this is 5 more wolves we've ever had, but look what the predicted population of the moose is if there were 30 wolves. It'd be all the way down under 600 to about 500, maybe 525 moose, okay, which is a big difference if we have a very small number of wolves. Okay, now you could talk about why that might be true. Maybe it's because, obviously the wolves are hunting the moose. You could make the other argument too, though, that in order for the wolf population to increase, well, no, I guess you can't. There'd have to be a lot of moose, but obviously the wolves are killing the moose. Okay, and so somewhere, if you were a wildlife management person, you don't want all wolves and very few moose, but you don't want lots of moose and no wolves. So you'd probably be shooting for someplace right in this area right here, okay, where you're kind of balancing the number of wolves and the number of moose, okay. And again, this is why we talk about scatter plots. So let's get to the why question here. Okay, so a scatter plot, we can talk about positive and negative correlations, but this is why. Come up with a trend line and then use the trend line. Notice that all of my predictions, let's do these in blue, all of my predictions here are on the trend line. They kind of ignore the scatter plot. So the scatter plot produces the trend line, and then from the trend line we'll make our predictions. Okay, and that's pretty much what you'll do with Mr. Johnson in 7th grade science. You do a lot of this, and it's what you'll do in a lot of science experiments. You do an experiment, your data is not going to come out perfect, but you'll get a rough idea of the relationship you're looking at. You graph a trend line, or sometimes it'll be a trend curve, and then you make predictions. Okay, so this is kind of where the rubber meets the road. That's really all I have. We're obviously going to be working on some word problems, so be prepared in class to draw some scatter plots, to formulate some trend lines, and then to answer some questions based on those. Okay? All right, so I'm going to sign off, and thanks for watching, and I'll see you in class tomorrow. Bye.